So the last piece to really add to your toolkit here this term is to zoom in on the nature of the firm. Now, hopefully you've taken a read through the reading. It's quite a bit. So let's think about, right up until now, what have we had? We have our law of supply, which is there's a positive relationship between the benefit to suppliers and the quantity that they supply. And so we basically had upward sloping supply schedules, and then as you add more firms in, we can do something like this, and maybe some idea comes in about elasticity, although that actually gets a little bit more technical. So I wouldn't necessarily worry about that here. But basically, one of the things we'd want to maybe understand is why are supply schedules upward sloping? We know why demand schedules are downward sloping. It's because substitutes exist. Substitutes exist for everything, and because people make decisions on the margin. So let's zoom out and let's think about an entrepreneur's decision about whether to produce or not. And so here we have quantity. And here I'm just going to put this in terms of dollars. Now, hopefully by now you know that what producers are going to try and do is going to be to maximize their profit. Now, their maximum profit may well be zero in a competitive market. But of course, we'd like our models to explain how we get there. So we know that this tends to go towards zero in a competitive market, and yet our tools up until now don't show that. So we need to kind of get more realistic and zoom in. Doesn't mean that what we've done up until now isn't useful. It's still what I use in a situation where I just need a quick answer, but I think it's worth here in our last few classes to zoom in and talk a little bit more specifically about this. So let's think about what happens. So we have profit, which is total revenue minus total cost. And for just a moment, let's focus on the total cost part of this. So if companies produce nothing, their cost is zero. They're going to be doing something else. However, when they produce the first unit, oftentimes there's what we would call fixed costs. If you want to produce any quantity, you're going to need to have some physical capital, some machines, a table, a location. And so the first few units are really costly to produce. So in other words, as you increase your quantity by a little bit, you have a big increase in cost. Then the marginal cost is going to drop off as we spread, right? So marginal cost and then average cost. And so what happens? And eventually we get something like this. It will still cost us more to produce more. Then we get to a certain place where eventually our factory is full of people and it is crammed with too many, right? We're running full tilt. And in order to increase production more, we're going to have to increase, right? We're going to have to build a new factory. We're going to have to buy new equipment, all of these sorts of things. And so then this will crop up again. Now, if we zoom out, some of you may realize that what this would mean is that we're going to have something like this as a cost function for an individual firm. I'm going to argue that this is going to continue to get bigger, this increase period. It's not going to be a straightforward. But what we're doing in effect is zooming in just on this chunk here. So hopefully that logic makes sense to you. So we have our total cost function that looks like this. And now the question is, what's our total revenue? So our total revenue, so say if the price is $1, for the first unit that we build, we're going to get $1. For the second, we're going to get $1. For the third, we're going to, right? So we're going to get an additional $1. And so our total revenue line is going to be a straight line where the slope is going to be equal to the price. So this would be our total revenue line when the price is $1. So now you can stop and ask yourself, what is the optimal quantity that a firm should produce in this instance? And hopefully what you're going to realize is that regardless of the quantity, so say we produce this quantity, this will be our total revenue, this will be our total cost, this distance here would be our negative profit. Less than zero, telling us to go do something else. On the other hand, if we produce this quantity here, this would be our total revenue, and this would be our total cost with this distance here as negative profit. It turns out, if you look at this, there is nowhere in here, given this total revenue line, that we should produce at. Actually, the best place that we can produce is 0. We can maximize our profit at a quantity of 0 and a total revenue of 0. Now, if I had a bigger board, well, we can look at what's going to happen here. So what happens then if the price goes up? Well, this line will shift up, because now instead of getting $1, we're getting $2 for each unit. So this is our total revenue line when the price is 2. And again, hopefully you realize that the best we could do here is going to be at a quantity of 0. And we can keep doing this. Eventually, we're going to get to where the where price has gone up enough that we have a total revenue. So as these shift up, there is a point at which we can produce and make 0 economic profit. Of course, what happens next? The total revenue line goes up. Now there's going to be somewhere where we can make positive economic profit. So this is an interesting case right here, which is if we produce less than this quantity, we're going to lose money. We're going to make negative, not just money, we're going to make negative economic profit. If we make more than that quantity, we're going to make negative economic profit. And so this is what we will call the minimum efficient scale. So let me see if I can put two things on the same graph here. And maybe this will be a train wreck. We will see. So here on this side, we have our total cost function. And we have dollars, and we have quantity. And over here, we can go back to quantity and price. And so basically what happens, at any price where this line is below here, what's going to happen is our optimal quantity is going to be 0. So 0 would be our quantity, 0, 0, 0. And then as soon as our price hits that point, what would happen? We would be willing to produce that quantity there. Now I'm not trying to do these on the same scale. I hope this isn't too confusing. Now the question becomes, what happens when our total revenue line shifts up again? And now you can hopefully see that anywhere in between these 2 points, we will be able to make more than 0 economic profit. Now, right here, we're going to make 0 economic profit, so we almost certainly want to produce more than that. Right here, we're going to make 0 economic profit, so we would want to produce a lower quantity than that. The question would be, is the quantity that we end up producing, is our optimal quantity less or more than this amount? So I'm going to try something here, and this is one that usually it takes us banging our heads into a couple times in class, but let's see if I can explain this. So let's take a situation like this. I think most of us can understand that if we would maximize this, what we're trying to do, remember, is to maximize this distance. So this point right here, so let's say this was our total revenue line. It turns out that we can, so again, if we increase to here, we're going to make positive economic profit. But again, could we increase our profit further? Yes, we could. And all I'm doing here is drawing in lines that are tangent to our total cost function. Once we get to here, it turns out that that line parallel to our total revenue function is going to give us the greatest distance. If we then increase our quantity, the line that is tangent to that point is no longer parallel here. And so you can play with this, but basically the upshot of this, so this is just basically our total cost and total revenue line shifted down. Now it's a little harder to see if I try and do this like this, but right here, that would be our profit. That would be our profit. That would be our profit. And that would be our profit. And so it turns out that this one here, that tangency, a line is tangent if it intersects a curve at one point and only one point. So this line is not tangent to this curve because it intersects twice. So it turns out that our profit will be maximized at the point where the line that is tangent to our total cost function is parallel to our total revenue line. And why does that matter? Well, let's take a look here. So if we go back here, our minimum efficient scale was there. So here we have total cost, here we have total revenue. And now this shifts up. Well, it turns out now the line that is tangent to this curve at this point is not parallel. And so it turns out that the line that will be parallel, big dots, is going to be out and to the right. And so the upshot of that is that if the price goes up now, it will make sense to increase your quantity. And then the same thing happens, and yes, I'm drawing very poorly. This is why I am an economist and not an artist, right? But so basically this will keep happening, yielding an individual firm's supply schedule. From our total cost function. Now, obviously, I mean, we could come up with some other stuff. Say we had a total cost function like this versus a total cost function like this. In this situation, as I've drawn it, the minimum efficient scale may be about the same, but the minimum price is going to be higher in this instance. And so we can obviously talk about different industries, and we can talk about different cost functions, and we can get more specific about what those pieces are. What that is going to do is going to affect whether our supply schedule, it looks like this, or maybe looks like this, or, right? But it's still going to look this same way. And so this is an individual firm supply schedule. It turns out, by the way, that across that relevant range, you can decompose this into a marginal cost and an average cost function. And these, yes, technically intersect right there. And it turns out that your marginal cost function has to intersect your average cost function at your minimum average cost. Stop for a moment, take that in. Your marginal cost function must intersect your marginal cost function must intersect your average cost function at your lowest average cost. Why? Well, let's think about this. For some of you, and I think many of you, your grade on the second exam was higher than it was on the first exam. So your marginal score was above your average score. So what happened to your average? It went up. When the marginal is above average, average must be going up. When your marginal is below average, your average must be going down. And so it turns out that your marginal cost function must intersect your average cost function at your minimum average cost. And in effect, if we then were to look at what's happening here, this and this are the same thing. Now, it should make sense. At any price below your average cost, you will, by definition, be making negative economic profit. So you're not going to stay in this market. You would go do something else. And so in order for you to produce anything, we're going to have to cover at least your average cost. So hopefully that setup makes some sense. Now, again, that's why we have the reading. Hopefully